Parallel resonance. A coil is connected in parallel with a capacitor and the combination is connected across the AC voltage source of variable frequency. Parallel circuit we considered here. Vector diagram for this circuit will be IC, this is voltage V, this is our IR. We'll find between the input voltage and the inductor coil current. Then this component is nothing but IL cos phi, and this component is nothing but IL sin phi. Let IC is the current through the capacitor, IL is the current through an inductor, and I is the vector sum of IL and IC, and V is the voltage source, VR is the voltage drop across the resistor, VL is the voltage drop across the inductor, VC is the voltage drop across the capacitor, and phi is the angle between V and IL, which is nothing but power factor angle, and this ZL is a coil impedance, XC is the capacitor reactance. Now IC is given by voltage divided by XC, IL is given by voltage divided by ZL, which is nothing but V by square root of R square plus XL square, which we can write V by square root of R square plus omega L square. Phi is given by cos inverse of R by Z. Now, at resonance, the capacitive current must be equal to the inductive part of the coil current. At resonance, IC equals to IL sin phi. Then IL is given by V by ZL, IC is given by V by XC, and sin phi is given by XL by ZL. ZL square equals to XL into XC, where sin phi equals to XL by ZL. ZL equals to square root of XL XC. XC equals to 1 by omega C, and XL equals to omega L. At resonance, this will be resonant frequency omega naught, then square root of 1 by omega naught C multiplied by omega naught L, which will be square root of L by C. This is our ZL. Let this be equation number 1. And ZL is nothing but this value. So substitute that square root of R square plus omega naught square L square equals to square root of L by C. Omega naught square L square equals to L by C minus R square. Omega naught square equals to L by C L square minus R square by L square, from which omega naught is given by 1 by L square root of L by C minus R square. Let this be equation number 2, from which F naught equals to 1 by 2 pi L square root of L by C minus R square. Equation number 3. Now, when you neglect the resistance of the coil, then F naught will become 1 by 2 pi square root of LC. That is equation number 4. This is our resonant frequency of series circuit. So at resonance, we have seen this IC equals to IL sin phi. The remaining part is IL cos phi, which equals to the current I. Now the current I is given by voltage divided by the entire impedance Z, which equals to IL, that is V by Z of L multiplied by cos phi, which is nothing but R by ZL. The entire impedance Z is given by ZL square by R, whereas ZL equals to square root of L by C. Substitute that, then you will be getting Z is given by L by C divided by R, which is nothing but L by CR. This is the equivalent impedance of parallel resonating circuit at resonance. This impedance is also called as dynamic resistance. If R is less, Z will be very high. When impedance is more, I will be less. Then this circuit is also called as resistor circuit. Now the current at the resonance, I equals to V by Z, which equals to V by L divided by CR. And as IL sin phi and IC cancels each other, Hence, the power factor of the parallel resonating circuit at a resonance is unity. The properties of parallel resonance. First one, the power factor is unity. Second one, the current at the resonance is given by V by L by CR, and which is in phase with the applied voltage. Now, net impedance at the resonance is given by L by CR. This is third one. Admittance is minimum and susceptance is 0 at resonance. This is the fourth property. And fifth one, the resonant frequency is F0 is given by 1 by 2 pi L square root of L by C minus R square. Now, profile of the circuit parameters with the frequency. Now, the resistance will be a constant value. This is R. The susceptance of capacitor is omega C, whereas the susceptance of the inductance is 1 by omega L minus. Then omega is 0, minus 1 by 0 is minus infinity to 0 as omega tends to infinity. B, susceptance belongs to inductance. Omega equals to 0. This is also 0. Susceptance of the capacitor, Z, which will be maximum at the resonant frequency omega naught, whereas the current will be minimum at the resonant frequency. These are current I. When you draw this impedance separately with respect to the frequency, this is F1, F2, F0, where F0 resonance frequency, F1 minus F2 is nothing but bandwidth. This is peak value. F1, F2 are known as half power frequency points.